Good morning, students. Welcome to the statistics class. I am S. Nirmala, Assistant Professor of Statistics. Today's my topic is Practicals on Descriptive Statistics. For the Semester 1 students, so the topic for the practicals is Descriptive Statistics. What are descriptive statistics and what are the measures, methods of collecting the data and putting the data in a tabular form and various diagrams and graphs, how to depict them and to know about the given data, what kind of data it is, and further what are the mathematical procedures or the statistical procedure we are going to do with the data, the definition of the statistics, various forms of diagrams, graphs, pictures, all these things we have seen in the theory class. Now today I am going to take up descriptive statistics. In descriptive statistics, the practicals. What are the practicals we are going to see in the descriptive statistics? So first one, we are going to see bar diagram. If a data is given, how can we make that data to be understood by the layman? You have data means it's a number. At the most what we can do, we can put the data in some tabular form. From that tabular form, we can the ones who know mathematics and statistics will draw certain information, but to a layman it's a table with some numbers. So if everybody wants to understand, we have to put the things in a pictorial form or diagrammatic form or any other form which will be attractive to the eyes, and with along with the attraction, it will give you an impression or an impression about the given data or the inference about the given data by having a look at it. Self-explanatory diagram, we can say that. So in a practical, what do we do is we take a data. For that data, how are we going to put them in a diagrammatic form? We will see. The first practical would be bar diagram. A survey of 145 people asked them which is the nicest fruit. So here is the data given. Now let us see. A survey of 145 people asked them which is the nicest fruit. So the people gave the answers. Fruit, and then frequent. apple, orange, banana, kiwi, blueberry, and grapes. The 35 people have said that the nicest fruit is apple, and then 30 oranges, 10 bananas, 25 kiwis, blueberry 40, and grapes 5. So this is the information a survey has collected with 145 students. They asked a question that which is the nicest fruit according to them. So there was 35 surveyors said that they like apple, 30 said oranges are the nicest fruits, bananas 10, kiwis 25, blueberry 40, grapes 5. So if this is the data, this we will draw a diagram called bar diagram, which is defined as a bar chart is a chart that represents categorical data with rectangular bars with height proportional to the value that they represent. Now we will draw a bar diagram taking into consideration our x-axis would be fruits. What are the fruits we have taken? Apple, orange, banana, kiwi, blueberry, and grapes. Grapes. Now the frequency, what is the least number? We have 5 and the highest number is 40. So 0 is the origin, 5, 10, 15, 20, 25, 30, 35, 40. Now apples are 35. So then oranges 30, bananas 10, kiwis 25, blueberry 40, grapes 5. Now look at this. The bar diagram is a chart which represents the categorical data with rectangular bars with heights proportional to its frequencies that they represent. Now apple is a rectangular bar which represents the apples. What is the frequency? 35. Represents the frequency of people who said that apples are the nicest fruit, have 35. So we draw a rectangular bar, x-axis to be your name of the fruit and y-axis is the frequency. Now you tell me now, if you are put it in a tabular form, how many would have understood? And if you put in a diagrammatic way, how many will understood? Here, if you have 100 people, lay people, that is, the people who doesn't know statistics, mathematics, economics, commerce or anything, if you ask them, they would clearly say that the people who like apples are 35, the people who say that oranges are the nicest fruits are 30. We need not explain to them anything. If we put this way, they doesn't know what is frequency and what is all this about. It is a survey conducted to know which is the nicest fruit out of all the fruits among 145 people. Now, if we show this or if we depict in a diagrammatic pictorial form, people will understand it is self-explanatory and we doesn't require anything to say about it. So this is a bar diagram. Second one we go to is multiple bar diagram. It's a simple bar diagram. You can call it as simple bar diagram also. You have frequencies of different variables and that you have put it in a single rectangular form. So this is a simple bar diagram. In the descriptive statistics, the simple bar diagram, you will be finding many examples for this. Now, where do you find this example? If World Cup goes on, let us say Cricket World Cup. From which country, how many hundreds in that tournament we got it. So, all the 7 nations, 8 nations which participate, they put it here. And the number of hundreds in India, let us say Rohit Sharma got 400 and Yuvraj Singh got 300, Dhoni got 200. So, we have 900 there. And in Australia, let us say there are 600. 2 or 3 people have hit the 100, 600. And if we say that England has 800, so we can represent in a bar diagram way. Usually if you watch the cricket, they'll be giving all this bar diagram details. Watching cricket, there are n number of people, in millions they'll watch the cricket, but nobody is going to teach them with this. The self-explanatory graph, they'll put it on the TV so everybody will understand. So this is a simple bar diagram, and one problem is I have shown you, and there are n number of examples which we can state. Now the second one is multiple bar diagram. These multiple bar diagrams are of 2 types. One is double bar diagram and the second one is triple bar diagram. That means what? We can compare 2 variables or 3 variables. Multiple doesn't mean that you can compare n variables, which is impossible. For multiple bar diagrams, we have 2 types of bar diagram. One is double bar diagram and the other one is triple bar diagram, wherein you can compare 2 variables for the double bar diagram, and triple bar diagram we can compare 3 variables. More than that, it will be very tedious, confusion. So multiple bar diagram name is that it will compare 2 variables or 3 variables. That's all. More than that we are not going to draw any multiple bar diagram. If they give you 6 variable and ask you to compare it, we will not put a multiple bar diagram for that 6 variable comparison. We will go into the further statistical methods where we can compare the 6 variables, but not with a multiple bar diagram. It fails there. Multiple bar diagram is used only if 2 variables are compared or 3 variables are compared. If 2 variables are compared, we use double bar diagram. If 3 variables are compared, we will use the triple bar diagram. Now we see the examples for it. 1. These are all practical problems which you have to record it in your records. Now, here. Birth rate. Death rate. Birth rate means number of children born to every 1,000 people in a given period or in a given year. The number of children born for every per 1,000 population. That's how we will calculate birth rate, and death rate also same thing. Number of deaths occurred in that period per 1,000 population. So that's how we will calculate. 1951 to 60, 1961 to 70, 1971 to 80, 1981 to 90, 1991 to 2000, 2000 to 2001 to 2010, 2011. That's all. Here 42, 41, 37, 32.5, 22.5, 7.3, 23, 19, 15, 11.5, 7.3, 5. Now how to draw double bar diagram? Here are the 2 variables which we are comparing. That means we can draw a multiple bar diagram. First one, the double bar diagram. How do we do? Our x-axis would be years and our y-axis would be the frequency. Now, years, what are the years? 1951 to 60, 61 to 70. So, how do we do? How do we depict this? Nineteen 1960, 1970, 1980, 1990, 2000, 2010. And y-axis frequency, the least is 5 and the highest is 42. So 5, 10, 15, 20, 25, 30, 35, 40, 45. Now, we have to compare birth and death rate. What is the birth rate in 42? Like this. 42. And the birth rate would be so this is your birth rate. And here 41. $37. And then 32.5. $22.5. And then 7.3. Now these are the birth rates which is given here. Now we have to put an index so that the one layman who is reading it should know birth rate. So we have taken a rectangular box with all crossed lines is nothing but birth rate. Now we see the death rates. What are the death rates? Let us see. In 1951 to 60 we have 23. Here it is 23. So these are the death rates. And then 19, and then 15, then 11.5, then 7.3, then 5. Here. Now we are clearly comparing the birth rates and death rates. There is no need of telling how the birth rates and death rates from the year 1951 to 2010, how it is decreasing, and how about the death rates? Death rates also decreasing, but the proportion of the decrease is very sharply deviation. Population was high and the death rate was high, and now as the population decreasing, death rate also decreasing. Why do you think the population is decreasing? Because the awareness has started among the people for having small families. From it is father, mother, 5, 6, 7 children. Now it has come to father, mother, 2 children or 1 child. So it is, the population has drastically decreased. Now if the population decreases and the facilities, other facilities increases, like medical facilities, cleanliness, everything will increase. That has impacted on the death rate also. Death rate also is drastically decreasing. Anybody who sees this and with this data can say easily that birth rates and death rates are drastically coming down, and they are positively correlated. Means what? If one is decreasing, the other also is proportionally decreasing. This is how, if the data is shown to a layman, he won't be able to have that clear picture. If the same data, if we put it in a bar or a diagrammatic or pictorial form, there the diagram will catch the eye, and the inferences to the people, layman, will be very effective. So this is multiple bar diagram with double bar diagram, that is 2 variables we are comparing here. We have to remember is that x-axis will take the variable which is of year, and y-axis is the frequency of death rates. Now birth rates and death rates, you draw it and then comparison will automatically be seen. You have to put the indexes, various what you are representing, you should be very clearly write the index. Okay, now we'll see triple bar diagram case. Country, France, UK, Mexico, Nigeria, Pakistan. The population. Indians. (1980) 1990 55, 56, 60. 80, 60, 82, 85, 57, 65, 70. Now here they have given countries and different time periods with their population. Now how to show it in a graph? Here we will put countries: France, UK, Mexico, Nigeria and Pakistan. So x-axis are countries. Now population. So France का population in 1980 is, no, frequencies. The least is 50 and the highest is 82. So 50, 55, 60, 65, 70, 75, 80, 85. Now here 55, 56, 65. So 3 time periods and the population of France. So first one is 1980, where you can mention 1980, 1980, 1990, and this is 2000. The population. And UK population would be 50, 53, 63. This is UK's population. And Morocco 65, 78, and then 80. So we can compare 3 with the different time periods and the frequencies, the population we are comparing. And then Nigeria 60, 82, 85. And then Pakistan 57, 65, 74. So this is how we are going to draw multiple bar diagrams. If we have 2 variables, we'll draw double bar diagram. If we have 3 variables for the comparison, we will have triple bar diagram. Okay, got it. Next we will see histogram. This is another form of depicting your bar diagrams. So, class interval 0 to 2, 3 to 5, 6 to 8, 9 to 11, 12 to 14, 15 to 17, 18 to 20, 21 to 23, 24 to 26, 27 to 29. And the frequencies are 7, 46, 165, 195, 189, 89, 28, 19, 9 and 10. Now you might have noticed in the bar diagram first practical problem we were studying the number of people who feels which is the nicest fruit. So our x-axis we have depicted with the fruits name: apple, orange, blueberry, kiwi, grapes. So we have depicted our x-axis with the names of the fruits, and then y-axis is the frequency. Thus and each fruit ka frequency we put a rectangular bar diagram separately. There is no connection. Now in the histogram we will have like this a graph of such a thing where it starts with x-axis and they will go hand in hand. They are connected. For that, here we cannot write apple, banana, orange, grape. So we have to use the class interval in such a way that, how do we use? We have to take a class interval which is continuous class interval. Here see, 0 to 2, 3 to 5. There is a break. In the histogram, between each bar there is no break. It should be continuous. This happens only if your class interval is continuous class interval. If there are breaks in the class interval, you cannot draw the histogram. Now how you will have this continuous class interval? We will see. First, if they give you not a continuous class interval, we have to make the class intervals continuous by the following method. You have to go further this way. This is 0.5 to 2.5. You should subtract 0.5 here. You should add 0.5 here and subtract 0.5 here. I'm sorry. You should subtract for 0.5 here and add 0.5 here. So now this will be 3 minus 0.5, 3.5 to 5.5. 5.5 to 8.5. 8.5 to 11.5. 11.5 to 14.5. 14.5 to 17.5. 17.5 to 20.5. 20.5 to 23.5. 23.5 to 26.5. 26.5 to 29 point. Now the frequency. Seven, 46, 165, 195, 189, 89, 28, 19, 9, 3. Now, x-axis your class interval. 0, 0.5, 2.5, 5.5, 8.5, 11.5, 14.5, 17.5, 20.5, let us see. And y-axis would be 3 is the least value, 7 is the highest value. Yeah, 195 is the highest value. So 5, 25, 25, 35, 50, 100, 150, 75, 100, 125, 150, 175, 200. Now you see. Now 0.7. Then 2.5 to 5, 46. Then 165. Then 195. Then 189. Then 89. Then 28. Then 19. So this is your histogram. You are going to see the values and then you are going to draw the histogram. Now if you identify your middle values, and with a free hand, if you join these points and touch your x-axis, then it is called frequency polygon. And this is your histogram. So the histograms midpoints, if you join with your free hand, you call it as a frequency, polygon, and this is your histogram. All the difference between bar chart and histogram is that in the bar chart each rectangle box will represent each variable, but here it is a class interval which is continuous, and your bars also touch each other and they will be continuous. This is the difference between bar chart and the histogram. If you join the midpoints of all the histograms and touch both sides with your x-axis, we call it as a frequency polygon. Hope you all understood this. For each of the problem, you take down the problem, you write the aim, you write the procedures which we have discussed in the theory class, how to draw a bar diagram. That will be your procedure. Then do the calculation, draw the picture and give the inference. So these are the things you should keep in mind and finish the practicals. If you have any doubt, please do contact me. I do clear your doubts. Thank you. That's all for today.